Okay, let us try to solve an example of latent heat of fusion word problem. So it says here, find the amount of latent heat of fusion and the heat energy used to raise the temperature at 40 degrees Celsius. What is the total heat energy used to change ice to water at 40 degrees Celsius? Show all your works. So to better analyze this kind of problem, we can make a diagram. So say for example, we have 100 grams of ice. So we have 100 grams of ice at 0 degrees Celsius. So let's encircle that one. It will change phase. So from ice, it says it will change to water. So the same amount of the same mass, 100 grams, that will change to water. There's no increase in the temperature here. This is only a phase change. So from ice, it changes to water. So the temperature is still at 0 degree Celsius. So, and then the other part of the problem is that the amount of heat energy used to raise the temperature at 40 degrees Celsius. So from this diagram, you have 100 grams of ice, of course at 0 degree Celsius. We have studied that in change of phase, melting. So we have 100 grams of water at the same temperature at 0 degrees Celsius. So you will see here that there's no changes in the temperature. There's only a change in the phase. From ice, it changes to, from solid, it changes to liquid. From ice, it changes to water. But the problem also says that how much energy will be used when this amount of water will be increased to 40 degrees Celsius. So this 100 grams of water will be increased to 40 degrees Celsius. So with this kind of diagram, it will help you a lot to analyze this kind of problem. So here, 100 grams of ice at 0 degrees Celsius changes its phase into 100 grams of water at 0 degrees Celsius. So this is only a change in phase. While on the other hand, this 100 grams of water at 0 degrees Celsius says that it will be increased to 40 degrees Celsius. So you will notice that from 0, it will be increased to 40 degrees Celsius. So you will notice here that there will be a change in temperature. So from 0 to 40 degrees Celsius. It's not yet boiling, but it's only at 40 degrees Celsius. So, how are we going to solve this kind of problem? Remember that when in change of phase, the amount of energy that will be used will be equivalent to energy, that's we will use the symbol Q, will be equivalent to the mass times the amount value of the latent heat of fusion. Why latent heat of fusion? Latent heat of fusion is the amount of energy of a certain substance. For example, water, we have here ice that changes to water. And the latent heat of fusion for water is equivalent to 80 constant, it's 80 calorie per gram. Meaning to say, in every 1 gram of water, the amount of energy that will be used will be 80 calories. So for this specific part of the problem, from ice to water, it changes phase from solid to liquid. We will use the formula Q is equal to ml, where m is equivalent to the amount in grams and L is the equivalent of latent heat of fusion for water, because we're talking of water. There are different constant value for the latent heat of fusion. Since we're talking of water here, the latent heat of fusion for water is equivalent to 80 calorie per gram. Okay? What about here? It doesn't change phase, but instead it changes the temperature. From 0, it increases up to 40 degrees Celsius. So remember that when there is a change in the temperature, we will use Q is equal to the mass times the specific heat. Since we're talking of water, the specific heat of water and the change in the temperature. So for this particular problem, you need to use two-step process. Here, because there's a change in phase, you will use Q is equal to ml. And then because here on the other side, the water changes its temperature, then we will use Q is equal to mc delta T. Delta T means change in the temperature. So shall we use, for example, since the problem is asking for the energy used to change its phase, let's use Q1. And on the other side, since the problem is also asking about the energy used to change the temperature, let's say this is Q2. Now, the last part of the problem, it says how much is the total energy. So meaning to say, in the whole process, excuse me, from 0 to 40 degrees Celsius, what is the amount of energy used? So meaning to say, we need to find the total energy. Shall we assign QT for total energy used? So in this case, we already analyzed the problem and we can do our calculation on how we will arrive with the total energy used. So we have, first thing is, when I'm asking you to do this kind of problem, I always ask you to write first the given. So write all the known values so that you will be able to understand it better. You have the diagram and then you write all the known values so that it will be easy for you to solve the problem. So given is the mass, right? Mass is equivalent to 100 grams. Then what other known information is in here? So we have, it starts from 0 degrees Celsius, so that will be our T1. So that's our T1 or TI, initial temperature. Sometimes we use TI, sometimes they use T1. T1 means the temperature at the beginning. So we have TI, or initial temperature, which is equivalent to 0 degrees Celsius. And then TF, or final temperature, which is 40 degrees Celsius. Known value, shall we write the known values here? Yes, you can, but sometimes the problem will not give directly the known or the constant values, like for example, the value of L, the value of C. But since we already discussed that, I assume that you already know the value of L and the value of C for water. Since we're only dealing with water, it's easy to remember that the latent heat of fusion for water is equivalent to 80 calorie per gram. While C, this C, specific heat of water, is equivalent to 1 calorie per gram degree Celsius. What does it mean? Calorie per gram degree Celsius. It needs 1 calorie to be able to raise the temperature of water, to be able to raise 1 gram of water to be able to increase the temperature of water. So shall we write that or not? It's if you already know the constant value, you don't have to. The only given value in the problem are the following: the mass, the TI, and the TF. So next, the next thing to do is I want you to write the find. What are we going to find? In this problem, we will find number 1. We will find the Q1. Teacher, where did we get the Q1? Q1 here, like what we have said, we're looking for the amount of energy used to change the phase from ice to water. So we assigned 1 as the first energy used to change ice, which is in a solid state, and that will be converted to water in a liquid phase or liquid state. So we will find Q1. Next, number 2. Since the problem is also asking about how much energy will be used when you raise the temperature of water up to 40 degrees Celsius. So from 0 to 40 degrees Celsius. So we assigned earlier, we will use Q2. So we'll write Q2 is equivalent to blank. We don't know yet. And then the last part of the problem is from ice in a solid state to liquid water, which the temperature is 40 degrees Celsius, how much energy, total energy will be used? So we assigned QT is equivalent to blank. So there are 3 things that we need to find: the Q1, the Q2, and the QT. QT is a total, not QT, I mean Q total energy used in the whole process. So let's make a separation here so that you will be able to. Next part is when you're calculating a problem like this, we always use a formula. So I want you to write the formula with your solution. This is what I mean when I say show all your works. You write the given, the find, the formula, and the solution, and then your final answer. So for a formula and solution, since we're trying to find 3 things, you start with finding the first one, which is the Q1. Okay? Q1 is equivalent to, like what we have said in our diagram here, we will use the formula Q is equal to ml. Teacher, why ml? Like what I've said earlier, ice in a solid state will only change phase, which is in a liquid state. Water, is there a change in the temperature? No. 0 degrees to 0 degrees, the energy is used to change the phase of the substance, which is the ice or the water. So we will use ml. Substitute the values, known value. We know the value of m, which is 100 grams. And then the L, which is a constant value, the amount of energy used to change phase from solid to liquid for water is 80 calorie per gram. Meaning to say, in every gram of water, 80 calories is needed to be able to change it to different state. In this case, we change from solid to liquid. So, cancel the unit. The unit that will be left behind will be calorie. Okay? So, 100 times 80 is how many? 100 times 80. 8,000. So, you have 8,000. 8,000 calories. That means that Q1 is equivalent to 8,000 calories. What you mean by 8,000 calories is that to be able to convert ice